do this. Last time we learned about classes and objects. We didn't finish that memory diagram. Oh, and I cleaned it out. Oh, shit. But that's what I want to do. I don't think the slides for today are going to take up the whole time, so I want to go revisit that memory diagram. And then Friday is another even bigger memory diagram. Today's content is slides only, though. So once we get done with the slides, we'll do what we can on that memory diagram. So there's a lot of neat things I still want to explain on that one. A big part of it is following the keyword this. So on Monday, I mentioned that we covered all the content you need to know for classes, at least for this week, and that will reinforce it. So for today and Friday, and today is going to be a lot of reinforcement. I'm going to talk about the same topics for the most part. I'm going to sprinkle in a little bit of extra content in there, but mostly the same stuff, but in a different context. So let's do exactly that. We've talked about array lists before. Array lists are classes. On Monday, we talked about what classes and objects are and how we can create this player class and objects of type player. And I mentioned, hey, by the way, array lists and hash maps, those were classes that we used to create objects of those types. So I want to crack that open a little bit more and explain what exactly the array list class itself does. And that really what I want to do today is dispel some magic. Like the array list class isn't magic. It's just Java code. That's the same kind of code that you can write with that we did with the player class. It's the same idea. Some extra stuff that we won't talk about until we get to, that's next week. Actually, next week we'll talk about type parameters. And I'll talk about that when we get there. That an array list can take a type like this. We will actually do that next week with linked lists. So we'll get that one. For today, we're going to ignore that part of it because I don't have time to explain it all in one day. So let's go on with this. So array list is a class. And we use that class to create objects of type array list. Just like we did new player, we do new array list, and that calls the array list constructor, which takes two parameter lists. It takes a type parameter list, which we're going to ignore today, and then the regular parameter list, which is just an empty list at this point. Since this is a method call, we're calling the constructor. Even if there are no parameters, we do still, I said parameter list, argument list to be technical. Since there are no parameters, the argument list is empty, but it still has to be there. Whenever we call a method, we need to have an argument list, so those parentheses need to be there. And this is what it looked like. We created an object on the heap, an object of type array list with all the values for our array list. And then we only store a reference to that array list on the stack in this variable of type array list. We think of R1 as a variable of type array list of integer, but it's actually a variable that stores a reference to an array list of integers. A subtle difference, but a very, very important difference. And then we use this dot operator. Array1 only stores a reference, and most of the time, we don't care about the reference. We don't really care that what OX200, OX200, we don't care about that. On our memory diagrams, we just make up numbers for the references. We don't care what the reference is. In 220, you will care to an extent what the references are. In 116, we don't care at all. Java doesn't even actually give you access to what the actual memory address is for your values because we don't care. What we do care about is the object that's being referred to, and to get to that object, we use the dot operator. So I have a reference stored in this variable R1, so the expression R1 will resolve to the reference OX200 in this example, and then dot says, hey, reference, take me to your object. So once we hit R1 dot, now we're following the reference over to the object, and once we're at the object, we can call methods on that object. Here we're calling the add method, and whenever we call a method for a non-static method, it will get a reference to the calling object. Here the calling object is OX200, the array list object at OX200, in the keyword this. Let's crack this array list open and talk about some details about how it actually works. Now, we're not going to go into all of the array lists, but what I have up here is the actual array list class, the actual code in IntelliJ, or in Java, in the JDK. And you know what, I might as well give a, oh my goodness. I have a lot of stuff open. No, let's do this quick. Oh, I'm regretting this already. Hold on. I don't have IntelliJ set up for lecture mode because I wasn't going to show it in lecture today. Bigger. Okay. If you go into IntelliJ and any type, if you go to that type and Control or Command click on it, it'll take you to the definition of that code in general. For a type, it's going to take you to the class that defines it. So if I Control click or Command click on my Mac, it'll take me to the array list class, and I can see all of the code that defines what an array list is. So this is the array list class in package java.util, array list class, and then all of the code for an array list. There's a lot of stuff here, but whenever you want to look at the nitty-gritty details of how things work in Java, Command click, it'll take you to the source code, and then you can look at whatever the hell you want to look at there, whatever you're trying to find. One useful thing for this is just what methods exist in the array list class. When I have an array list, what can I do? There's a method called set that takes an index and an element. If you want to insert a value at a specific index, there it is. It just happened to be on the screen, so I picked on that one. Get, size, we know those ones. Remove, if you want to remove the value at an index, you can know exactly what you can do with an array list by looking at its source code, like this. Okay. So that's what I'm doing here, except I'm going to, you saw how much code there was. I'm not fitting all that on the slide. So I am significantly trimming down the code of an array list. Here I have almost nothing, but we're going to add to it. I'm going to slowly add a little bit more of the source code of the array list as we go through this. But this is going to be the actual source code for an array list, just significantly trimmed down, so I'm not talking about literally everything that defines an array list. So for now, we have the package declaration, java.util. That's the package that this lives in, or the directory that this lives in. And the class defined is ArrayList. This is in a file called arraylist.java. It has to follow the naming convention. All Java code has to follow the same naming convention. So when I import java.util.arraylist, package java.util, class ArrayList, we know those things already. We know that has to be the case, the package and class name, because that's how we imported it. We know that's going to be the case. And then we're calling a constructor new ArrayList with no arguments. Then we know that there is a constructor for an ArrayList that takes no parameters. So there is an ArrayList constructor. The actual ArrayList code has a public ArrayList constructor that takes no parameters. And the type parameter stuff, that's actually part of the class itself up here. Again, we're going to ignore that. But wherever you see E in the code, for this example, E would effectively be replaced by integer. That's my one-sentence explanation for it. We'll talk about it quite a bit more next Wednesday. We'll get to that stuff. And notice that the constructor is not static. We talked about that last time. We're pretty much done. Aside from our main methods, we're done with static methods for the most part for the rest of the semester. There'll just be a few exceptions here and there, but most methods are non-static at this point. So new, this is how we call a constructor. Constructor has no explicit return type. New constructor. And then this resolves to a reference to the array list that was created. And we can overload methods. This is, I don't have a great place to talk about overloading methods, so I want to talk about it right here. But this topic is important throughout all of Java. You can have multiple methods in the same class with the same name. That is allowed. We have here two constructors for the array list. And we can do this with other methods. We will see another example of this today. You can have regular methods, non-constructors, that have the same name as other methods in the same class. It's called method overloading. This is allowed as long as they have different parameter lists. So this constructor takes a parameter. This constructor does not. Therefore, we are allowed to write both of these, and then depending on the parameters that you give the constructor, that's going to determine which one of these methods is actually called, which constructor is actually used to create that array list. So if I say new array list with open paren, close paren, no arguments, I'm going to get this constructor. If I give it arrays.asList, like we saw, like was my tip for making testing the average method a lot easier, if you're doing it like this, what you're doing is using the other ArrayList constructor, using the overloaded constructor that takes a collection of something that extends E. Again, syntax we don't have to worry about. This syntax, I actually will never talk about this semester. Unless somebody asks, I'd be happy to talk about it. But we don't know inheritance yet, so we can't really talk about it quite yet without going on a big tangent. So we might not do that. What you just showed us, what would have to type in our program if we didn't import? Wait, what? Is what you just showed us, would it be what we would have to type in our program if we didn't import? Oh, yeah. So if you don't have this import, you could do java.util.ArrayList. Can you do that in Java? I don't think I've ever tried that. I think you can. I'll leave it at that. I think you can without importing. And you type java.util.ArrayList. But when you do this, then you only have to type ArrayList because it's now imported into your project as ArrayList. I'll table that. If we go back to IntelliJ, you know what? Now it's bugging me. Okay, no, Java doesn't allow that. This is because I didn't do it here. Oh, no, it does let me. Okay, so yeah, you can type it. And what I do know, if we import, I knew this one 100%, if we import Java, then I'm wrong on that one. You know what? Let's go back to the slides. But you can type the whole thing. This just makes things easier, so we just type ArrayList. Just like on your problem set testing, you could import static average and import static the three methods, and then just call the methods directly without having to do problem set dot and then the method. Just like we import static assert true and assert equals, we can do that same thing as well, as long as we get that code. Okay. And classes have state and behavior, or objects have state and behavior, rather. Classes do too, but it's less interesting. The state of classes is something we don't really use too often. It's just not super useful. But objects can have state and behavior, and that is extremely useful throughout your entire career, all the time. Very useful. The state are all the variables, all the instance variables for that object, and then the behavior are all the non-static methods of that object. And some people might include static in there too. I don't know. I don't, but that's the state and behavior, variables and methods. And actually, I do want to talk about this right now instead of later. So we'll expand on this, but the way an array list works in Java is it actually does use, and I mentioned this in an earlier lecture, but it does use a vanilla array, just a plain old array, an actual array of objects for what it's worth, underneath the hood. So that's what an array list really is a wrapper class for an array. So you could use arrays directly and rebuild what the array list does for us, or use the array list and use the better ease of use, all these quality of life features that array list adds to an actual array. But it does just use an array. When I say arrays can't change size, that's true. That's a fact. Arrays can't change size. You can never. Have I said that before in lecture? I'll say it Monday if I haven't said it already. I think I did. But arrays can't change size on a tangent. I think I said it. Arrays can't change size. This array can never change size, but the array list makes us pretend that it can change size by adding extra functionality on top of it. And then another piece of state, another instance variable to track the size of the array list, which will not necessarily be, will almost always not be actually, the same as the size of that array for reasons. If main is static, how can it call a non-static method? By creating an object and then calling a non-static method through that object. You can't call it directly. If you're in a non-static method in a class, you can't just call a static method, you can't just call it directly, immediately, but if you create an object of that type and then that object, a reference to that object dot, and then the method, it's that object that's calling the method, which is allowed for non-static methods. But main can't just do, like from a main method, you can't just say like size. You can't just call size. You do some array dot size, and that's fine. And what we use constructors for is to initialize the state. Any state that we want to have initialized for each object, we're going to do that in the constructor. In this case, we wouldn't want to, we're not actually taking any parameters, but we don't want to set this right in line here because this constructor is not going to take this same default value. So if you don't give this any parameters, you get the default empty, default capacity empty element data. Very descriptive name. I like descriptive names. I ain't complaining, but it is a long name, which is just an empty array. So you're initialized to an empty array. The size is initialized to 0. Oh, I don't like this. Size is initialized to 0. If you don't initialize an int, it's implicitly initialized to its default value of 0. So they're leveraging that and not being very explicit about that, which is fine for internal Java code, whatever. But size is going to be initialized to 0, and element data is initialized to an empty array. That's what you get when you use this one. The overloaded constructor, there's a lot of code here, too much for the slide, but it'll take all of the values you give it, create an array that's big enough to store all those, set the size equal to the number of elements, all the stuff you would expect it to do to initialize that initial state of the object. In our case, the initial values in this object array and the initial size for how many elements that array is currently storing. And we also have another constant. This is the second one we'll see this semester. We don't see too many. Might be the second of two when I think about it. But our second constant, this is a static variable. This is the same array for every single array list ever because it belongs to the class, not the object. That's what static means. This belongs to the class, not the object. And it's a constant. We don't want anyone changing this. And this is the array that's used just as the default empty array for every single array list. So each array list isn't creating its own empty array. It does save a little bit of space for what it's worth by reusing that, having it a private static final variable. We got a bit of stuff going on. There should probably be questions. Oh, there are questions in chat. So give me your questions if you have them. So does a class array list create a new array of different sizes and copies elements over to the other array of same name to give us the illusion the array of an array with changing size? Yes. Sounds an empty array would be defined as empty brackets instead of hash map as braces? Yes. It's weird. I don't know why they chose this syntax. Coming from Python, that looks like an empty dictionary or an empty hash map. It's just what the syntax is. And there is no equivalent key value store. Like array is a very special type of object in Java using this bracket syntax. There's no equivalent of a key value pair in Java that it's its own special thing. We'd have to use something like a hash map, which doesn't have any special syntax. A hash map is just a regular object defined by a class using code like this. Array list isn't anything special, but arrays are special with special syntax. Nothing else has that bracket syntax to access elements by index like that. So it's allowed to use whatever special syntax it wants, and it does mix brackets and braces. For what it's worth, Java came before. Can I even say that? I don't know. I don't know if this is 100% true. Java came before Python. Java was very much so popular way before Python was popular. I can say that for sure. But technically, the first time somebody in a research lab somewhere just wrote a few lines of code and said, this is called Python, I'm actually not 100%. How do you decide? Oh, and I wanted to go back to the earlier question. When you run out of room in that array for an array list, what the array list will do when it runs out of space in the underlying array is it'll create a brand new array with double the capacity, double the size as that array, copy all the values over, and then get rid of the old array. So that's how it's giving you the illusion of increasing size, by constantly running out of space and creating new arrays somewhere else in memory. Yes? Yes. Private, static, final. So we got 3 keywords, each doing something else to this thing. Private means we can't access this variable from any other code outside of this class. So anything in between this brace and this brace, any code in there can access this variable, but outside, no. Static means this belongs to the ArrayList class itself, not the ArrayList, not objects of type ArrayList. So we access this, I think it's my next slide or a few slides from now, ArrayList dot default capacity. This is the way it looks in the code, but I modify it in a few slides to make it explicit. ArrayList dot is how we would access that, not a reference to an ArrayList dot. So not by the object, but by the class itself. And final means we can't ever change this. We can never say default capacity empty element data equals and reassign it to a new value. Final says we can't do that. Static is I think the big one there. It belongs to the class, not the object. We have this distinction between classes and objects. We use classes primarily to create objects. Static is saying this belongs to the class, not objects of this type. How do you decide a method or variable belong to the class or not? So how would you decide whether to use static or not? That's a pretty big question. The general rule of thumb is if for variables, if it's a constant should be static. If they're not going to change, why are you going to have a copy of that constant for every single object you create? That's just a waste of space. If it's a constant, put it in the class itself, and now you only have to create one copy of that constant. It's not going to change. Why have more than one copy of it? For methods, if that method depends on the current state of an object, then it should be non-static. If it doesn't depend on the current state of the object, so if it doesn't rely on any of the instance variables, it should be static. And in this course, I will violate that from time to time, even on homeworks and stuff. I'll violate that in a few spots, just because it's easier to say everything's non-static from here on out. But there are a few where it just absolutely made no sense to have them be non-static. So there are a few that are still static because it was too much of a violation that I couldn't do it. Java was released 4 years after Python? Oh. I know that because I know Python's been around a lot longer than it seems like, because Python was around for a long time before it became popular. That's why I had to hesitate a lot. And I was wrong. I was right to hesitate. Java started as Project Oak. They should have kept that name because it sounds cool. Project Oak. I feel like I'm going to go on a Pokemon adventure with that one. Yep. Yes. So any code that's going to run in an ArrayList object has to be defined in the ArrayList class. So they would have access to this private variable. And public static variables are accessible everywhere, anywhere. They import the class and then class name dot whatever. And we did get ahead of the slides a little bit, which is good. I like that because we'll reinforce it when we get to those slides. it'll just make more sense. All right. And then all of the non-static methods are part of the behavior of objects of this type. So an array list object, there are certain methods that you expect there to be, certain methods that we use. We only used 2 so far, get and add. So we have the get and add methods are defined in this class, and here's the code. This is the whole code. It fits on the slide, so I put these in their entirety on the slide. Get does what you would expect it to do, goes to the array, uses the bracket syntax like we're used to in Python, and grabs the value at that index, and does this thing that I don't want to talk about because don't do this on your homeworks because you'll break things. But typecasting this object, this reference of type object to a reference of type E, where E is your type parameter, and then returning that value. And then I don't think I've seen someone use typecasting without breaking the assignment. Whatever reason why that was their solution, they had a bigger problem that led to that. And then add. Add, give it an element. This is how you call add on your side. The code of how it actually does it internally, this is it. This is how it adds to an array list. And this does use a helper method. So the add method is overloaded. We have a public and a private add method, and the private add method has more parameters. We got a lot going on here. I won't explain it all in full. I'll explain a little bit. Grow, this is the method that will double the size of the underlying array. I don't have the grow code on the slide right now. I just wanted to talk about helper methods. And so when you add an element, it's going to add it to that array, and if the array is filled up, it's going to grow, create an array of double the size, and then add it to that new array after copying all the values over. But what I want to talk about is overloading. So this is happening in the constructor. It's also happening in the add method. We have 2 add methods with different parameter lists, and that's perfectly fine. We call it a helper method. When we do more recursion, we're going to see a lot more helper methods. Starting next week, we'll see quite a few helper methods, so I want to get the idea out there right now. We're going to have one method that's called, and then another method with different parameters that's going to do the recursion. That's the recursion helper method. So this is valid syntax. Java lets us do this. Everything's perfectly fine with this. Compiles, runs, works great. And we have the keyword this all over the place. Let's talk about it. So we just introduced this keyword Monday, so it's probably still pretty fuzzy. Let's talk about what it is. This is a reference to the object that called that method. And in the case of constructors, it's in reference to the object that's being created. So in the constructor, this is a reference to the object that's being created. And then we can use that reference to access its state and behavior. In this case, this element size, give me the variable, the element size, or element data, instance variable from the array list that we're currently creating and set it equal to this value. In size, this is a method that's called through an array list object. So you have a reference to an array list object in, say, R1. R1 dot means take me to your object, and then we call size from that object. So now the size method is being called from that object. In the size stack frame, we'll have the keyword this that stores a reference to the array list that called that method, or the calling object, I usually like to say it. A reference to the calling object. And then return the size of that array list. So this dot, go over to that array list in memory, in the heap, grab its size variable, and return it. And same thing throughout. We're going to access that object that's being referred to by this, which is the object that called that method. And the behavior of these methods will depend on that reference. So if we get the value at index 0, we want to go to the actual array list that called this. You said r1.get. Okay, R1 is the array list that we're concerned with. We want the state of that specific array list. If you have 5 array lists in your code, we want that specific one that you have a reference stored in R1. That's the array list that we go to add this, or to get this element out of its element data variable. Because each one of those 5 array lists will have its own copy of element data, a variable named element data that refers to an array of objects somewhere else on the heap, which we don't worry about the nitty details of all that, but an array list will have a reference to another object on the heap, which is an array list of objects, which will have references to other objects. We don't worry about it that far. And public and private. Let's talk about this. So public, we've mentioned this quite a bit. This one should be feeling pretty familiar at this point. Public means you can access that code, that state or behavior from anywhere. Any code, anywhere. You, in your code, import array list. You can call all of the public methods for an array list and none of the private methods. Private methods can only be accessed inside the braces that define that class and from nowhere else. From outside of those braces, you cannot access the private state and behavior. So why would we make things public or private? Well, encapsulation. That's my answer. Encapsulation is the idea of hiding implementation details. Most people don't care how the ArrayList class works. Like, I'm using it as an example today, but you don't have to understand all the internals of an ArrayList, not until CSE 250 anyway, about how it works. What you care about is that it has these two constructors. If I want an empty array list, I use the first one. If I want to populate it with some data with arrays.aslist, I use the second one. I want to be able to ask it for its size. I want to be able to get elements out of it and add elements to it. That's the basics of what you want to do. And you might have a few extra methods that you want to call on your array list. That's fine if you want to look at a couple other ones. Removing elements, inserting into a specific location. You might want to do those things. But this will get you off the ground. These are the methods that we use. You don't care, or maybe you do. I don't know. Maybe you do. But you don't have to care. You don't have to care that its add method is overloaded with a private helper method that takes 3 parameters. You don't have to care. So what the Java developers do is make that a private method. They hide the details of how the add method actually works and just expose the public interface of an add method that takes one element. Because that's what you want. You want to say, hey, ArrayList, here's an element. Store this thing for me. And then you want to forget about it. You don't want to know how it stores it, that it's resizing this underlying array. Like, the reason we use an array list is so we don't have to worry about those little details. If we wanted to worry about those details, we just use a plain array and then resize it on our own. We don't want to. We don't care that that array even exists. It's private. We don't care. We don't care that it has a separate size variable that's tracked independently of the actual size of the array. We don't care about any, or rephrase again, we don't have to care about any of that. We don't have to. So make it private. Hide the details. This is a concept called encapsulation. It's a good idea to do. It's a powerful thing in computer science. It lets us use things without having to get bogged down with all of the details. So whenever you have details that aren't important to the end user, or not necessarily the end user like of the software, but of whoever's using your code, somebody else on your team who's importing your code, if it's not important to them, make it private. Hide the details, and then expose the API. So all the public methods, this is how people will interact with your code. This is what we call the Application Programming Interface API, which is a very overloaded term in computer science and programming. It generally means, the general definition, is it's a way that two pieces of code interact with each other. This is our API, or public API, I usually call them. This is how other people will interact with this code, and this is what we as users of the ArrayList class care about. So if it's something that other people need to use, make it public. That's your public-facing API. Oh, and your state should always be private. I'm hesitant to say the word always because there's going to be some exception out there, but your state should be private. Your state of objects should be private. Static variables, as we're going to see on the next slide, so I can't contradict myself really quickly, but static constants being public is perfectly fine. We already mentioned that constants shouldn't be non-static because that doesn't make sense. And static variables are accessed through the class name. I added this ArrayList dot, so I did one small modification to the Java code just to make it clear that this is how you would access the variable from outside the class. From inside the class, when we use this variable name, Java's going to say, well, I don't see that variable in the stack frame anywhere. What it will do is continue its search. It will look at the reference this, follow that reference to its object, and look for a variable with that name in the object. It's not going to find it there either. So then it's going to continue its search to the class, the containing class itself, and look for a static variable with that name, and it will find it right here. So we're just relying on Java finding that variable, but if we put ArrayList dot, we're guaranteed it's going to find it, and it's going to find the right variable with the name, because if we reuse that name, it's going to find the wrong one. And it's clear to other people reading this code that this is accessing a static variable, or a static constant in this case. And if we are outside, not in this example because it's private, but if we're outside of the ArrayList class and we wanted to access a public variable, we would do ArrayList dot and access that variable, which we're going to do right here. So sometimes it makes sense to have a whole mess of static methods and variables in your code. And one notable example is the math class. The math class, you have never, ever in your, you've been coding Java for a few weeks, but you'll never in your Java career say new math. You're not going to do that. You don't have to do that. It's not how the math class works. What the math class is a collection of a lot of static variables and methods, well, a lot of static methods and just 3 static variables, public static variables anyway. So if you want e, pi, or tau in your code, you would do import, math is auto-imported, math.e, math.pi, math.tau, and you would access these static constants in the math class, so we don't all have to have in our code the variable pi equals whatever, double pi equals whatever. They're constants in the math class, and we have 2 more constants. I don't know why they made these private. You know, the rest of us could have made use of these constants, but for some reason, the Java developers decided to make our radians to degrees conversions and vice versa private, but it is what it is. We'll just have to take pi here and compute those. It's not that big of a deal, but why make those private? Like, why make those private? Just make them public. And the math class actually does have a constructor. And there's one case where you're going to see a private constructor, something that almost never makes sense, but for the math class and classes like this, where it's just a collection of static methods, it does make sense here. So we have a private constructor, meaning you can't create an object of type math. Unless you do some fancy stuff, you can use reflection, and if you know what that is, you could do that. But there's no reason to, because everything in the math class is static. If you have a math object, you can't do anything with it. It doesn't do anything, so there's no point to it. Doesn't do anything. And then all the methods are static as well. So if you do math.abs, like we've already done, that's the one math method that we've seen, math.abs, you're accessing a static method that's a member of the math class. That's what's happening when we do that. Yeah. If you don't have a good question. If you don't have a constructor, you get what's called the default constructor, which is the same as this one, except it's public. So if you just don't write a constructor, you get yourself a free public constructor that takes no parameters and doesn't do anything. So if they didn't have the private constructor, they get the default one, and then people can do new math, which wouldn't really hurt anything, but let's not pretend that that does anything. Just shut off the constructor completely, and then there's no question to other developers. New developer, you might be tempted to say new math at some point. You type new math, you get a compilation error, and then you say, oh, that's not how Java works, and then you don't do it. Give specific examples on what should be public and private. 4 minutes ago, was that before I talked about public or private? If you want other developers to call the method, make it public. If you don't want them calling the method, make it private. That's my, in a nutshell, explanation. Is E just a generic type, or is it specific? It is literally called a generic type. Again, we'll talk about that more next Wednesday, but it's basically a placeholder for whatever type you give it. So array list of integer, E is going to be integer for that specific array list object. Array list of double, when you create an array list of doubles, E is going to be double for that specific array list. So E is going to be replaced by whatever type you give it in the type parameter when you create that array list. Okay, then let's talk about toString. So toString is going to convert your object to a string. I guess that's straightforward. And when you print your object to the screen, our player object that we didn't write any toString method for, we'll get what's the default behavior, which is to print out some garbage that looks like this. It's going to be the fully qualified name of your class, the @ symbol, and then some random hex value that doesn't mean anything to us. It means something to Java, but it doesn't mean anything to us. And that's pretty useless in pretty much every single scenario ever. There's no reason to ever do this. So what we can do is implement a toString method. If we have a method called exactly toString with a capital S that takes no parameters and returns a string, this method will be called by println. And then when we print our object, this method is called, and whatever this returns, that's what's printed to the screen. And it gives us a little more utility out of our print line debugging, which we should be using unit testing at this point anyway. But gives us a little more utility for print line debugging. And if we ever actually do want to create a string out of an object to display that string to the user, this can be quite helpful. And what we did when we created a class is create a brand new type. We created a brand new type in Java. So when we created this player class, we now have a player type, which can be used wherever a type can be used, including as parameter types, variable types, not on screen, but as type parameters. I can have an array list of player. And I'm missing one, return types. I don't have it on screen here, but the return type of a method, wherever I can use a type, I can now put player once I write this class. Just like array list used to not exist, a team of developers sat down, wrote the array list class, and then we can use array list all over our code. We're defining new types whenever we create a new class. Okay, and let's get to this memory diagram at least a little bit. I think I'll just, is it going to be? So I did create one. It's in the slides from Monday. I think it's going to be a little too hard to see, though. There's just too much stuff. And I don't have time to recreate it in lecture. Let's try this. Because there's one key thing that I want to make sure I point out is the keyword this. Whenever a method is called, so like here we have p1.setName. We're calling the setName method. P1 stores the reference OX002. So I'm saying P1, take me to your object. That takes me over here to this object at OX002. And then I'm calling the setName method. So when I put setName on the stack frame and any of these non-static